Hi, what I want to do right now is give you a little bit of a summary of what we did in the last lecture. And I'm going to try to do a little video like this each week. A very short video just to recap on what was covered. So it won't be fully comprehensive of absolutely everything that we did in class, but at least it should get the main points. So you get the big picture of what was going on and what were the main points being covered. So the question right now you might want to say is, well, what is this course about? What do we mean by this module, biometric authentication in general? What does that mean, and what's coming up in this module? So the thing that I want to go through here is just to recap on what we did already. There are a few points that are common to all of the biometrics that we cover, regardless of whether it's fingerprinting, face recognition, or whatnot, that are important to know. And the first one here, I've just numbered them 1 to 6. The first one is the ID versus verification. The difference between these two is very, very important. As we mentioned, to ID someone asks the question who you are. So just to be aware, you could be dealing with quite a lot of people there. The database could be quite big to ask someone to try to identify someone who isn't telling you who they are. It's not the same as just verifying somebody who is claiming to be somebody. So when you talk about verification, the question is, are you who you say you are? For example, if you were to just enroll first on your phone and log on using some sort of face recognition tool, that's verification. And it's very different from IDing someone. Remember, if you're trying to ID someone from CCTV, the size and the searching involved are very different. And those things make a big difference when we look at the other biometrics that we're gonna come across on the course, because the size and quality of the search that you do will make a huge impact on speed and on performance. So just number 2 here, we're talking liveness detection. Liveness detection is really a sort of anti-circumvention technique. If you're trying to circumvent a system, and there are many ways to do so for all of the biometrics. One little kind of fail-safe mechanism is to check for liveness, to check if this is really an actual person trying to be verified or ID'd, rather than someone maybe just using some sort of hack like a photograph or a fake fingerprint or whatnot. So liveness detection will come to the fore in absolutely every biometric that we look at in this course, because whether it's face recognition, fingerprinting, or retinal scanning, there's ways to circumvent all of these. There's attempts to circumvent all of these things. A system of liveness detection must be put in place for all of the biometrics in order to avoid that attempts at circumvention. Now, number 3 here, I just have mentioned formal testing of biometric systems, and that's pretty important for you, especially in terms of assignments. But let's not talk about that right now in this video. I still want to keep it very short. The formal testing of a biometric system is done in a very specific way, quite common and similar to what you might have done for your penetration testing. Really, you're just looking to look at an entire system and get some numbers. And the numbers, two of the things you want to get are its false reject rate, how many people have been rejected falsely. For example, if this guy really is his phone and he gets rejected for whatever reason, well, that's a false reject, because he's not up to anything. It really is his phone. So if it doesn't accept him, if it doesn't verify him, it's a false reject. Or you might have false accept if somebody manages to actually circumvent that system. So you just use a certain number of tests. You end up with a percentage: false reject, false accept. There's some others, failure to enroll, for example, but we won't worry about those right now. It's a big part of the course. I'll make another video about that and how to formally test the system. It's not very difficult, but it's something that you need to get right. In terms of the processing of these things, we will have to look at some algorithms. Now, you know what these are from your programming experience, but in order to run them effectively, it really doesn't matter how effective the algorithm is if the piece of data hasn't been pre-processed first. So all of our photographs that we might take, or images, will have to be pre-processed because they've got to be simplified in order for the algorithm to work quickly and as effectively as possible. So for example, the photographs for face recognition will have to be converted to grayscale and kind of just basically scaled down quite significantly to run any algorithms upon them. So hardware is another point I want to just mention. Hardware will play a big role in pretty much all of the biometrics. It's going to make a big difference, especially for some of the more common things like fingerprinting or iris scanning. Now, well, why is that? Because you may say, well, if the algorithm works, what's the big deal about hardware? Well, that's why I wanted to show you the diagram like this today, because it all sort of fits in together as one. Because sure, an algorithm may work very well for fingerprinting, but if someone's trying to circumvent that, and you have a system of you want to place a system of liveness detection in there, well, it's really the hardware that takes care of that. So let's just take that fingerprinting as an example right now and discuss that for a minute. If someone might try to make a fake fingerprint of some kind that they've picked up somewhere and try to circumvent your system, whether that be your the home key in your phone or some other type of reader. Well, it's the hardware that checks if someone is actually trying to circumvent it or not. And how would it do this? In terms of the fingerprint, it might look for some sort of electromagnetic electrical signal that comes from the human body, and if the hardware can test that it's not perhaps in the right limits or something is weird going on because a fingerprint might be covered up, well, then it will know that something is going wrong. There's no real liveness there, for example. It might be easier described in terms of face recognition at the moment, because with face recognition, your face is really three-dimensional, isn't it? So somebody putting a photograph in front of your phone to try and pretend it's you, may have been able to do that in the past. But a system of liveness detection would be, for example, to check for movement, to check for the 3D structure of the face, to check for even heat signals or facial thermograms. Now, you may recall last week that the iPhone X was released, and what they're claiming is that it actually has a face recognition algorithm to replace the fingerprint verification that they used to have. You'll notice that there's no home key on it, for example, and it's claiming to be 20 times more effective than the former fingerprint system that they used to use. Now, yeah, this is true. It's certainly more effective, way more effective than the former face recognition algorithm. And the reason it seems to be so is because they're using an infrared technique. They're claiming it's using a laser technique. I need to look into it a little bit more. But it gets a 3D image. It can create a three-dimensional image of the face. So by creating that three-dimensional image, it's clear that there's an actual kind of body of the structure that's looking at the phone, like it's an actual real head, if you like. It's not just a photograph or some other video that's moving, and that is an example of liveness detection. So it would be quite difficult for somebody to actually recreate a moving bust, a moving model of your head that's three-dimensional, and it's moving around, and it looks exactly like you and makes the same movements as you. And that's why that's what seems to be happening there. So really the work has gone into the liveness detection there, by the sounds of it. But I will look into that a little bit more, and hopefully we'll be able to demonstrate that exact software in class. And one more thing, a little thing about that, just to get back to that concept again, is in terms of hardware. Well, the hardware involved is a lot simpler than the sheer magnitude and size of the hardware that you would need to incorporate good liveness detection for fingerprinting. Because with that iPhone X, with the face recognition system that they've got in place there, it just relies on a camera, and I believe there's also an infrared camera in there as well. So this is not requiring it is very complex hardware, and the phone it certainly costs a pretty penny, but it's not very big. It's not very bulky hardware that's in use. It fits onto an actual telephone. It fits on a phone, on a smartphone. Now, if you compare that to what you might need to do serious liveness detection for a fingerprint scan, well, you might, if you want to do liveness detection for fingerprinting, you might be looking at things like the kind of vein pattern underneath the fingerprint, the ultraviolet scanner there. You might be looking at the electromagnetic pulse. That's the pulse even itself, just to get the pulse, or some sort of electrical signal that's coming from the finger to show it's really a human finger there. You haven't just kind of created some silicon faked plastic structure to log on to a system. Well, that will demand an awful lot of hardware that really was always going to be very, very difficult to place onto a smartphone. So that's potentially one of the reasons maybe that they've gone over to face recognition. Face recognition has certainly had an enormous renaissance, if you will. It's had an enormous comeback in the last year or two because of this effective liveness detection in terms of getting a three-dimensional scan that works in real time. If you can do a three-dimensional scan and check that it's get good liveness detection, the 3D image is actually moving, it's not just sort of a photograph that you're trying to scan up against something, then that becomes a much more powerful biometric than a fingerprint, because it's easily accessed, it's accessible, and it's usable. And I just realized I haven't talked about the final one there, which is the multimodal systems, but that just basically means using a multiple pronged attack. So rather than just putting all the eggs in one basket and using one biometric, use two of them. If it's so fast, if the hardware is working so good these days, use a combination of face and fingerprint, or iris scanning and voice, or whatever it is. And that just makes things all the better, because you're talking about 2-3-factor authentication there. Now, here's the list of biometrics that you called out when I was asking about them in the class there. You can see there's quite a lot of them. You've got the ear, the fingerprint, the eye, the retina, the vein pattern, etc. And notice that these are categorized as image-based ones. So the pre-processing involved, just like I mentioned, if you want to run the algorithm on these effectively, they've got to be pre-processed in a certain way, because they're images. They're all image-based. For example, the palm print, the vein pattern, the face, even the eye biometrics, the retina, the iris. The other ones that I've kind of focused on here are the signal-based biometrics. For example, the voice, the EEG, keystroke, the walk, the gait, the way somebody's walking. And there's much more, but we'll just keep it small for now. These are signal-based biometrics, and those are the two main kinds we'll be looking at on this course. So, for example, our major signal-based biometric will be the voice. We'll be looking into patterns and frequencies within that identify, give someone's voice away in terms of identifying them. Now, there are other ones. There's, for example, there's DNA, there's dental, odor, etc. But I really don't want to go too far into them on this little clip. I just want to keep it very short as just a recap on what we covered last week in the lecture. Okay, so I hope that helps. I'll go over all of this again anyway, very, very briefly, just to recap at the start of the next lecture. And, you can give me any feedback about the kind of stuff you might want to put into the videos in terms of maybe some lab materials or whatnot. But I'll try and kind of put something together for you that's comprehensible each week. So thanks for listening, and I'll talk to you in the next class.